5. F block elements. Blueprint. Part 1, 2 1 mark question. Part 2, 1 5 mark. That is question number 54. So, under the F block elements, you are having lanthanides and actinides. Any group of elements following lanthanum are called lanthanides, and following actinides are called actinium element are called actinides. Lanthanides have the oxidation number of +3. Suppose you are moving from left end to the right end, the size of ion starts to decrease. Because all the additive electrons have been added to F orbital. F orbital has the least screening effect. Since its effect is very least, screening means covering from the nucleus. The F orbital covers the electron from the nucleus, but it is not efficiently covering. So, due to inefficient covering or inefficient screening of F orbital, there is a much more attraction between nucleus and the electrons. They have been attracted towards the center. So, obviously, the size shrinks. It is called lanthanide contraction. Similarly, in actinide also the contraction occurs. Suppose one size of ion decreases, acidic nature increases, but basic nature decreases. The lanthanides are extracted from monocyte sand. The lanthanides are extracted from monocyte sand. So, extraction of lanthanide from monocyte sand. Monocyte sand is an oxide basically. So it is concentrated by gravity process. The monocyte sand initially heated at 210 degrees with sulfuric acid for several hours. So what's happening? The powdered monocyte sand is heated with concentrated sulfuric acid for several hours at 210 degrees C. While doing so, a grey colored mud has been formed. A grey colored mud. Further, the grey colored mud has been treated with cold water. The grey colored mud is treated with cold water. Here, unreacted monocyte sand has been created. Unreacted monocyte sand. In addition to the unreacted monocyte sand, you are having SiO2, TiO2 and zirconium silicate. Likewise, all have been obtained. It is called recycled sand. Then filtrate has been obtained. The filtrate containing all the lanthanides, lanthanum, thorium, likewise. They are neutralized by acidity. So HF has been added. While neutralizing, followed by hydrochloric acid, they separated and treated with NaOH and oxalic acid. Finally, lanthanides are formed in the form of lanthanide hydroxide or lanthanide oxalates. The lanthanide actinide comparison is very important in this chapter. In the case of lanthanides, the binding energies of 4f electrons are higher. The binding energy is higher. Suppose they are lanthanides and actinides. 1. Binding energy of electrons, 4f electrons, is higher. But in the second actinides, binding energies of 5f electrons are lower. Maximum oxidation state exhibited by lanthanides is +4. Actinide shows +4, +5 as well as +6. 4f electrons have greater shielding effect. Shielding effect means covering from the nucleus. 5f electron has poor shielding effect. So when comparing with 4f and 5f, 4f may efficiently cover the orbital from the nucleus. Lanthanides are paramagnetic. Actinides are also paramagnetic, but their magnetic properties are very difficult to interpret. Lanthanides do not form complex, but actinides have the tendency to form the complex formation. Except promethium, all are non-radioactive in the case of lanthanides, but in actinide, all are radioactive. Lanthanides compounds are less basic. Actinide compounds are more basic. Lanthanides do not form oxocations, but actinides form UO2 plus, UO plus, LpO2 plus, PuO3 plus. Actinides are used in uranium-235 fissionable. It is used as a fuel in nuclear organic plants. Platinum-338 is used as a power source in long transmission sources.